Okay, so here we have this problem where it's basically asking us what would be the value of k, if any, will this be a solution to this differential equation. So you have this differential equation, and you want to determine under what circumstances, if any, will there be a k value that makes this a solution to this differential equation. All you need to do here is basically you need to make sure that you take the derivative correctly, because what I need is the second derivative of this function. So I got y prime, and I'm just going to look over at y, and I'm going to differentiate this piece by piece. So the derivative of k sine 5x, okay, that's going to be k times the derivative of sine 5x, right? So what is the derivative of sine 5x? The derivative of sine 5x is cosine 5x times 5. And I'm going to put the times 5 in front of the k. That's by chain rule. Plus 2 times the derivative of cosine 4x is going to be negative sine 4x times 4. Okay, so I'll put times 4 here, and I'll make this minus. And then I'll rewrite everything. So it's going to be y prime is equal to 5k cosine 5x minus 8 sine 4x. And that's my first derivative. That's y prime. Now y double prime is what I need, because I need to plug in for y double prime. I of course already know y. Y is this, and I want to see if that's going to be equal to negative 27 sine 5x. This left-hand side of it equals this right-hand side. So I need y double prime still, right? So I need to differentiate this again. Y double prime. The 5k is just some constant that's being multiplied. The derivative of cosine 5x. And if you need to, take your time with it. I did it quick in the other case, right? But the derivative of cosine 5x is negative sine 5x times 5. And now this is times the 5k. So I'm going to get negative 25k sine 5x minus 8. And then what's the derivative of sine 4x? Again, the derivative of sine 4x. Again, know your chain rule, right? The derivative of sine u, right, is cosine u times u prime. So in this case, it's cosine 4x times 4, where I just put the 4 in front. And then that's times 4, so 8 times 4 is 32. So I'm going to get 32 cosine 4x. And that's y double prime. Now let's see if this indeed is going to... Now what do I need to do here? I set this, right, in for y prime, and I start solving my differential equation, right? I substitute in to that differential equation. So the differential equation is y double prime plus 16y should equal negative 27 sine 5x. So what do I have here? Well, y double prime is negative 25k sine. I'm going to run out of room, so I'm just going to start writing a little bit smaller. Negative 25k sine 5x minus 32 cosine 4x plus 16 times y. Y is this whole thing. Y is k sine 5x. And I'm going to cheat a little bit here. I'm going to write 5 plus 2 cosine 4x should equal negative 27 sine 5x. Okay, so I'm running out of space here. I shouldn't do that. You guys should be very careful with how we do this. Now I have what here? Well, oh, and I got to remember this was distributing. It's 16 times that, right? Because it's 16 times y. Y was this, and the inside this is y, right? This was the y that I plugged in right here. And then this was y double prime, all this here. Now I'm going to distribute that 16, so I'll rewrite it where I have a little bit more space. So I'm going to write the whole thing over here, let's say. So I got negative 25k sine 5x minus 32 cosine 4x. And I'll just write plus 16k sine 5x plus 32. Because when I distribute the 16, so 16k sine and it's 32 cosine 4x should equal, okay, and I'll write it up here just a little bit over, negative 27 sine 5x. Okay, that should equal that. Now let's see. So here I got some like terms, which is good. And the good thing is that this cancels with this. Why is that good? Because it makes it possible for there to actually be a solution. Then negative 25k sine 5x is a like term with the 16k sine 5x. What do I get? I get negative 9k sine 5x needs to be equal to, and now I'm just writing this side, negative 27 sine 5x. And now I'm pretty much good, because what is this force? This force is negative 9k to have to equal to 27. So what's the k value that will make this true? Well, divide by negative 9 sine 5x on both sides, and you will solve for k. Negative 9 sine 5x on both sides. This cancels. Negative 27 over negative 9 is positive 3. Sine 5x, negative 9 and negative 9. I just get k on the top. K is 3. And that is my value for that first one. Now let's see what we got. We got here. Okay, now this one I think is a little bit more work. These ones where they put the choices. Yikes. Ugh, okay, let's take our time. Let's see what we got. Okay, which of the following are solutions to the differential equation y double prime minus 10y prime plus 9y equals 0? So the only way I see doing this is to sit here and take our time with each one of these possibilities. So y is equal to 2 sine 3x. Okay? And then I'll try and do it all in, going down 5e to the x, and then the last one is y is equal to c e to the 9x, where c is some constant. Okay, so let's go through each one. Y prime, you're gonna need a y prime, right? So and you need y double prime, so you definitely need to go through y prime. The derivative of 2 sine 3x is 6 cosine 3x. Take your time with that if you cannot do that fast. Okay, be sure. The derivative, the 2 comes out, the derivative of sine 3x is cosine 3x times the derivative of 3x, which is 3, and then the 2 times the 3 in the beginning becomes that 6. Y double prime is negative 18 sine 3x. Again, take your time if need be on how to get these derivatives. The derivative of cosine u is negative sine u times u prime. So the derivative of cosine 3x is negative sine 3x times the derivative of 3x, which is 3. So it's negative 3 sine 3x. And then negative 3 times 6 is negative 18. Okay, now let's check to see if it's a solution. My differential equation is y double prime minus 10y prime plus 9y should equal 0. Now let's check. Y double prime is negative 18 sine 3x minus 10 times y prime is 6 cosine 3x plus 9, y is times 2 sine 3x. And let's see what we get here. It should equal 0. So I get negative 60 cosine 3x plus 18 sine 3x, and I don't see it canceling, right? Because this is going to be 18 and 18. That gives me 0, but I still have this negative 60 cosine 3x, so it is not this one, which makes it between B, C, and D. Okay? Now let's check this one, y prime. And this is an easy one, nice. So we got an easy one. The derivative is just 5e to the x. The second derivative is 5e to the x. And now let's see if we get a solution. So again, I write my differential equation, y double prime minus 10y prime plus 9y should give me 0. And in this case, they're all the same thing, so it's 5e to the x minus 50e to the x plus 45e to the x, and I believe this does give me 0, right? Because 5 minus 50 is negative 45, so this left-hand side is indeed 0, and now I have that 2 is one of them. So now it's only between B and D. So now you got a 50-50 shot. Now let's see, y double prime, and this is going to take some time. This says 9. Make sure you guys see that as a 9. I apologize if it looks like a 4. That's a 9x. Now, what is the derivative here? It's c times the derivative of e to the 9x. But by chain rule, that is going to be 9c e to the 9x. Because I multiply by the derivative of 9x by chain rule is 9. And that's where I get that 9 from. The second derivative of this is going to be 81c e to the 9x. Because again, I multiply by 9 again, right? The derivative of e to the 9x is again 9e to the 9x. So I get that other 9. 9 times 9 is 81. Substitute this into my differential equation. Y double prime, I write the differential equation, minus 10y prime plus 9y equals 0. Y double prime is 81c e to the 9x minus 10 times 9 is 90 c e to the 9x plus 9 times that is 9 c e to the 9x. Now the question is, does this equal 0? So 81 minus 90 is negative 9 c e to the 9x plus the 9 c e to the 9x is 0, and this is indeed a solution. So this is a solution and this is a solution. So your choice is D, and you're done. Okay, you have to go through all three. I don't see an easier way to do it. Maybe if you're clever, you could eliminate the first one somehow. If you could foresee, if you do a lot of practice with these, you could foresee somehow. But I don't see how to do that right now. I've been doing these for some time now. I don't know how to do it. But maybe you could eliminate one real quick. But other than that, just sit here, find the first derivative, second derivative, plug it into the differential equation. See if it's a solution, right? Go find the first derivative, second derivative, plug it into the differential equation. See if it's a solution. This one was, and this one was. Okay?